Good morning, students. I hope all of you are fine today. So, let's continue with the chapter which we are doing in our online classes, that is work and energy. Now, students, today's topic is law of conservation of energy. So, what do you mean by conservation, students? Conservation means saving the energy. So, what it is? As we know that students, energy can be transformed or it can be changed from one form to another. So according to the law of conservation of energy, it means whenever energy transforms or changes from one form to another, then the total amount of energy remains constant. So in other words, if energy changes from one form to another, then there will be no loss or gain of energy. The energy will be constant, students. So in simple words, we can say that energy can neither be created nor be destroyed. For example, students, when electrical energy is converted into light energy in an electrical bulb, then some of the electrical energy is wasted in the form of heat. So, although some energy may be wasted during conversion, but the total energy of the system remains the same. So that is why during the conversion of energy from one form to another, some amount of energy may be wasted. Okay? So let us take an example. Now students, if you just look at the picture, suppose we have a ball of mass m and we have raised it to a height h, which is above the ground. Now the work has been done while raising the ball, which gives its potential energy, that is, the energy has been stored in the ball, which will be equal to mass into acceleration due to gravity into height. Now, let us allow the ball to fall downwards. Now, as soon as the ball falls from the height h above the ground, it will decreases, okay, and thus the potential energy which is stored initially after lifting the ball to a height, it will also get decreased. But students, as the ball falls, then its velocity v will increase constantly, and therefore the kinetic energy, that is the half mv squared, will also increases. Now as the ball falls more and more, its potential energy gradually converted into an equal amount of energy. But students, remember one thing, that the sum of potential energy and kinetic energy of the ball remains the same at every point during its fall. So, when the ball just reaches the ground, then its potential energy becomes zero. Now, at this stage, all the potential energy has been converted into the kinetic energy. So, from this, we can say that the potential energy which has been stored in the ball, it has been changed into an equal amount of kinetic energy. So this proves that there is no destruction or loss of energy, and the total amount of energy remains constant. Okay? Now just if you look at the picture, students, it is the conservation of energy during the free fall of a ball. Now in the first position, that is the position A, the ball is at rest. Now suppose it has the potential energy of 20 joule, but the kinetic energy is 0. So the total energy of the ball at position A, it will be 20 plus 0 equals 20 joules, students. Now the ball falls down and reaches to point B. Now it has lost some potential energy and it is changed to 15 joule, and kinetic energy being increased to 5 joule. Then also students, if you see, the sum of potential and kinetic energy will be 20 joule as well, that is 15 plus 5 equals to 20 joule. Similarly, at point C, the potential energy has been decreased to 10 joule and kinetic energy has been increased to 10 joule again. So if you add both these energies, then it will be also 20 joule. In this way, students, when the ball just before hitting the ground, see, the potential energy of the ball is 0 joule, but the kinetic energy of the ball has been increased to the 20 joule. So then also it will be 20 joule itself. So it is clear from the observations that the ball falls downwards, its kinetic energy decreases. In the same time, its potential energy decreases, and in the same time kinetic energy also increases. Okay, so the total energy of the ball remains constant. So this proves that the energy of a freely falling body remains conserved and remains constant, students. Okay, students, so that's all for today. In our next class, we will continue with the chapter. So thank you for today, class.